All right, well, let's go ahead and ask what sort of response we might make to this argument. Although it may come as something of a shock to many, it seems to me that the most dubious premise of the above reasoning is premise 1, that STR is correct. In order to understand why, let's recur to Newton's distinction between absolute and relative time. While it is easy to find statements by prominent physicists and philosophers to the effect that STR destroyed the concept of absolute time and so forces us to abandon the classical concept of time, such verdicts are based almost invariably upon a superficial understanding of the metaphysical foundations of Newton's doctrine of absolute time and space. We've already seen that Newtonian time is absolute, both in the sense that time is distinct from our physical measures of time, and in the sense that there is a unique, all-embracing time. But as is well known, Newton also conceived of time as absolute in yet a third, more profound sense. Namely, he held that time exists independently of any physical objects whatsoever. Usually, this is interpreted to mean that time would exist even if nothing else existed, that we can conceive of a logically possible world which is completely empty except for the container of absolute space and the flow of absolute time. But here we need to be very careful. Modern secular scholars tend frequently to forget how ardent a theist Newton was and how central a role this theism played in his metaphysical outlook. In fact, Newton makes quite clear in the general scholium to the Principia, which he added in 1713, that absolute time and space are constituted by the divine attributes of eternity and omnipresence. He writes, "He is eternal and infinite. That is, his duration reaches from eternity to eternity, his presence from infinity to infinity. He is not eternity and infinity, but eternal and infinite. He is not duration or space, but he endures and is present. He endures forever and is everywhere present. And by existing always and everywhere, he constitutes duration and space. Since every particle of space is always, and every indivisible moment of duration is everywhere, certainly the maker and Lord of all things cannot be never and nowhere. Because God is eternal, there exists an everlasting duration, and because he is omnipresent, there exists an infinite space. Absolute space and time are therefore quasi-relational in that they are contingent upon the existence of God. Newton does not conceive of space or time as in any way attributes of God, but rather as concomitant effects of God. In Newton's view, God's now is thus the present moment of absolute time. Since God is not a dwarf God located at a particular place in space, but is omnipresent, there is a worldwide moment which is absolutely present. Newton's temporal theism thus provides the foundation for absolute simultaneity. The absolute present and absolute simultaneity are features first and foremost of God's time, absolute time, and derivatively of measured or relative time. Thus, the classical Newtonian concept of time is firmly rooted in a theistic worldview. What Newton did not realize, nor could he have suspected, is that physical time is not only relative, but relativistic. That the approximation of physical time to absolute time depends not merely upon the regularity of one's clock, but also upon its motion. Unless a clock were at absolute rest, it would not accurately register the passage of absolute time. Moving clocks run slowly. This truth, unknown to Newton, was finally grasped by scientists only with the advent of relativity theory. Where Newton fell short then was not in his analysis of absolute or metaphysical time. He had theological grounds for positing such a time, but in his incomplete understanding of relative or physical time. He assumed too readily that an ideal clock would give an accurate measure of time independently of its motion. If confronted with relativistic evidence, Newton would no doubt have welcomed this correction and seen therein no threat at all to his doctrine of absolute time. In short, relativity corrects Newton's concept of physical time, not his concept of absolute time. Of course, it hardly needs to be said there is a great deal of antipathy in modern physics and philosophy of science toward such metaphysical realities as Newtonian space and time, primarily because they're not physically detectable. But Newton would have been singularly unimpressed with this verificationist equation between physical undetectability and non-existence. The grounds for metaphysical space and time were not physical, but philosophical, or more precisely, theological. Epistemological objections fail to worry Newton because, as John Lucas nicely puts it, he is thinking of an omniscient, omnipresent deity whose characteristic relation with things and with space is expressed in the imperative mood. Modern physical theories say nothing against the existence of such a God or the metaphysical time constituted in Newton's thinking by his eternity. What relativity theory did, in effect, was simply to remove God from the picture and to substitute in his place a finite observer. Thus, according to historian of science Gerald Holton, the relativity theory merely shifted the focus of space-time from the sensorium of Newton's God to the sensorium of Einstein's abstract Gedankenexperimenter, as it were, the final secularization of physics. But to a man like Newton, such a secular outlook impedes rather than advances our understanding of the nature of reality. So, I ask, what justification did Einstein have for so radical a move? How did he know that absolute time and space do not exist? The answer, in a word, is verificationism. Historians of science have demonstrated convincingly that at the philosophical roots of Einstein's theory lies a verificationist epistemology mediated to the young Einstein chiefly through the influence of Ernst Mach, which comes to expression in Einstein's analysis of the concepts of time and space. The introductory sections of the 1905 paper are predicated squarely upon verificationist assumptions. These are seen most clearly in Einstein's operationalist redefinition of key concepts. The meaning of time is made to depend upon the meaning of simultaneity, which is defined locally in terms of occurrence at the same local clock reading. In order to define a common time for spatially separated clocks, we adopt the convention that the time which light takes to travel from A to B equals the time it takes to travel from B to a definition which presupposes that absolute space does not exist. For if A and B are at relative rest, but moving in tandem through absolute space, then it is not the case that a light beam will travel from A to B in the same amount of time that it takes to travel from B to A, since the distances traversed will not be the same. And look at the two clocks at relative rest, both moving absolutely. The light ray goes from A and finally reaches B at T2. It is reflected back to A at T3. And look at the much greater distance that is traveled from A to B than from B to A. That's why Einstein's theory, far from disproving the existence of absolute space, actually presupposes its non-existence. All of this is done by mere stipulation. Reality is reduced to what our measurements read. Newton's metaphysical time and space, which transcend operational definitions, are implied to be mere figments of our imagination. How then shall we assess the claim that STR has eliminated absolute time and space? The first thing to be said is that the verificationism, which characterized Einstein's original formulation of STR, belongs essentially to the philosophical foundations of the theory. The whole theory rests upon Einstein's redefinition of simultaneity in terms of clock synchronization by light signals. But that redefinition assumes necessarily that the time which light takes to travel between two relatively stationary observers, A and B, is the same from A to B as from B to A in a round-trip journey. That assumption presupposes that A and B are not both in absolute motion, or in other words, that neither absolute space nor a privileged inertial frame exists. The only justification for that assumption is that it is empirically impossible to distinguish uniform motion from rest relative to such a frame. And if absolute space and absolute motion or rest are undetectable empirically, therefore they do not exist and may even be said to be meaningless. In a clear-sighted analysis of the epistemological foundations of STR, philosopher of science Lawrence Sklar underlines the essential role played by this verificationism. I quote, "Certainly, the original arguments in favor of the relativistic viewpoint were rife with verificationist presuppositions about meaning, etc. And despite Einstein's later disavowal of the verificationist point of view, no one, to my knowledge, has provided an adequate account of the foundations of relativity which isn't verificationist in essence. It would be desirable to do so, muses Sklar, but what I don't know is how to formulate a coherent underpinning for relativity which isn't verificationist. But if verificationism belongs essentially to the foundations of STR, the next thing to be said is that verificationism has proved to be completely untenable and is now obsolete. The untenability of verificationism is so universally acknowledged that it will not be necessary to rehearse the objections against it here. Richard Healy observes that verificationism has come under such sustained attack that opposition to it has become almost orthodoxy in the philosophy of science. Verificationism provides no justification for thinking that Newton erred, for example, in holding that God exists in a time which exists independently of our physical measures of it and which may or may not be accurately registered by them. It matters not a whit whether we finite creatures know what time it is in God's absolute time. God knows, and that is enough. It's difficult, therefore, to understand how many contemporary philosophers and physicists can still speak of STRs forcing us to abandon the classical concepts of space and time, or of STR's destruction of Newtonian absolute time. Lawrence Sklar concludes, the original Einstein papers on special relativity are founded, as is well known, on a verificationist critique of earlier theories. Now, it might be argued that Einstein's verificationism was a misfortune to be encountered not with a rejection of special relativity, but with an acceptance of the theory now to be understood on better epistemological grounds. But I don't think a position of this kind will work in the present case. I can see no way of rejecting the old ether compensatory theories originally invoked to explain the Michelson-Morley results without invoking a verificationist critique of some kind or other. With the demise of verificationism, the philosophical underpinnings of STR have collapsed. In short, there is no reason to think that premise one is true. Now, I'm not here endorsing Newton's view on divine eternity, but I am saying that the theologian who, like Newton, believes God to be temporal need not feel threatened by STR, because STR's claim that absolute time does not exist is founded essentially upon a defunct and untenable epistemology. Let me pause at that point and see if there is any discussion of that response to the argument.
We've got a question from Christian Meister online. So does that mean Newton technically held to a relational view of time?
Does that mean what?
Does that mean that Newton technically held to a relational view of time?
Well, I call it quasi-relational. He didn't think it's relational in the sense that there needed to be events going on, which is what normally a relational view of time holds. But it's quasi-relational in that he thought that it was contingent upon the being of God. That is, because God exists, that time and space exist.
So if absolute time exists, like the Newtonian concept of an absolute time, and abstract objects are an affront to divine aseity, then how would Newtonian time not also be an affront to divine aseity?
Well, on Newton's view, absolute time and space are concomitant effects of God. So far from making God contingent upon space and time, they are contingent upon God.
But wouldn't the divine conceptualism of abstract objects hold that same view concerning abstract objects?
Yes, that's right. The divine conceptualist will say that these thoughts that God has are dependent upon God. That's correct. But you'll remember my critique of that was that God's thoughts don't seem to play the role very well required by these abstract objects. It would require God to be thinking of an infinite number of bawdy and banal and silly thoughts all the time that are unworthy of him, that the notion of exemplifying thoughts is difficult since thoughts are particulars, not universals, and that thoughts don't seem to be sets. I wouldn't have any access to sets if they're in God's private consciousness. So the critique of divine conceptualism that I offered was not that they wouldn't be contingent upon God. Indeed, they would, but rather that divine thoughts don't seem to play the role very well that is played by various abstract objects.
Couldn't the time relation be basically the exact same thing? That absolute time would just be God's thoughts, so to speak.
Yes, that's an alternative. In fact, I like that idea better than Newton's. Remember, I said on Newton's view, there don't need to be any events for time to exist. God could be absolutely changeless, and yet absolute time would flow on. But for someone like Leibniz, who held to a relational view of time, there would need to be at least events in the mind of God going on in order for absolute time to exist prior to the beginning of the universe. So in that case, the succession in the contents of consciousness of God would be sufficient for the existence of an absolute time. Indeed, I think that that is a knockdown argument that time is not identical to physical time, to our measures of time. Namely, it's very easy to conceive of God having a succession in the contents of consciousness which would be sufficient for time, even in the absence of a physical universe. And so time is distinct from our measures thereof.
Let's move to a question from Dan Miller online. If God occupies a reference frame independent of our time measurements, what is it that God sees me doing in my now? Are my clocks running slower or faster than his? Am I doing something different in my time than an observer, where clocks are running at a different rate to mine?
Perhaps that would be a good segue to the next section, which will, I think, helpfully answer that a little bit. Skipping several paragraphs, I come to the paragraph that begins, so what would become of STR if God is in time? What would become of STR if God is temporal? From what's been said, God's existence in time would imply that Lorentz, rather than Einstein, had the correct interpretation of relativity theory. That is to say, Einstein's clock synchronization procedure would be valid only in the preferred absolute reference frame, and measuring rods would contract and clocks slow down in the customary special relativistic way when in motion with respect to the preferred frame. Such an interpretation would be implied by divine temporality, for God in the now of absolute time would know which events in the universe are now being created by him and are therefore absolutely simultaneous with each other and with his now. This startling conclusion shows that Newton's theistic hypothesis is not some idle speculation, but has important implications for our understanding of how the world is and for the assessment of rival scientific theories. Lorentzian relativity is admitted on all sides to be at least empirically equivalent to Einsteinian relativity, and there are even indications on the cutting edge of contemporary physics that a Lorentzian view may be preferable in light of recent discoveries. In fact, due to developments in quantum physics, there has been what one participant in the debate has called a sea change in the attitude of the physics community toward Lorentzian relativity. Let me skip ahead and quote from the eminent physicist J.S. Bell on the implications of the results of Bell's theorem. He says, I think it's a deep dilemma, and the resolution of it will not be trivial. It will require a substantial change in the way we look at things. But I would say that the cheapest resolution is something like going back to relativity as it was before Einstein, when people like Lorentz and Poincaré thought that there was an ether, a preferred frame of reference, but that our measuring instruments were distorted by motion in such a way that we could not detect motion through the ether. That is certainly the cheapest solution. Behind the apparent Lorentz invariance of the phenomena, there is a deeper level which is not Lorentz invariant. What is not sufficiently emphasized in textbooks, in my opinion, is that the pre-Einstein position of Lorentz and Poincaré, Larmor and Fitzgerald was perfectly coherent and is not inconsistent with relativity theory. The idea that there is an ether and these Fitzgerald contractions and Larmor dilations occur, and that as a result, the instruments do not detect motion through the ether, that is a perfectly coherent point of view. The reason I want to go back to the idea of an ether is because in these EPR experiments, there is the suggestion that behind the scenes, something is going faster than light. Now, if all Lorentz frames are equivalent, that also means that things can go backward in time. And this introduces great problems, paradoxes of causality and so forth. And so it is precisely to avoid these that I want to say that there is a real causal sequence which is defined in the ether. Moreover, in a truly astonishing development in 20th century cosmology, we may even have a good idea as to what is the preferred reference frame, and this would respond to the online questioner. For the cosmic microwave background radiation, first predicted by George Gamow and then discovered in 1965 by A.A. Penzias and R.W. Wilson, is at rest with respect to the expanding space of Big Bang cosmogony. It is therefore a sort of ether, serving to distinguish a universal rest frame. Recent tests have even detected the Earth's motion relative to this background radiation, thus fulfilling the dream of 19th century physics of measuring the ether wind. What 19th century physics could not detect using visible light radiation, 20th century physics discovered using microwave radiation. Philosopher of science James Cushing connects the universal preferred frame defined by the microwave background radiation with the unique frame in which absolute simultaneity is required by the experimental results of Bell's theorem, proclaiming, today, the ether has re-emerged through quantum phenomena. One can only speculate, had these facts been known to Einstein in 1905, he would ever have suggested that absolute space and time does not exist. Any other comments?
I just have a question personally. Was Einstein a theist?
I don't think so, Cameron. There's a lot of speculation about this because he often talked about God. But for him, God was Spinoza's God, which is just the universe, or a sort of rational principle behind the universe. I don't think Einstein believed in a personal deity.
So given that the universe is still expanding, the ether would be what it's like expanding, like towards?
No, the ether or the microwave background information, the
Radiation.
microwave background radiation fills expanding space. And so as the expansion continues, the microwave radiation expands along with it and serves to define a privileged frame, which measures what is called cosmic time, and that is the proper time of the duration of the universe. When scientists say the universe is about 13.8 billion years old, they're not talking about relative to our frame of reference. That is the measure of the proper duration of the universe in cosmic time, which is the same for all observers in the universe, regardless of their state of motion.
Okay.
And in answer to the online question, I mentioned that we've actually measured the Earth's motion relative to the microwave background radiation. It turns out we're moving in the direction of the constellation Leo, and our speed is such that Earth time and cosmic time are pretty close. They more or less coincide. So that if he were to ask, well, what is God's time? Ironically, it's pretty much Earth time. God's time is pretty much Earth time because Earth time coincides with cosmic time in our vicinity.